So we'll take a look at this problem. This came out of WAMAP. It's interesting. I think it's a randomly generated problem that had oddness happen in that two ships leave from this point. One of them's traveling this way at 28 miles per hour. The other one's going this way at 28 miles per hour. I'm thinking that would, for some people, those might have been different. But I'm going to do it first of all with those being the same. They both travel for 3.1 hours, which I calculate 28 miles an hour times 3.1 hours is 86.8 miles. The question is, how far apart are they? If I draw a straight line, that's supposed to be straight. The thing is, this is early on in the quarter. I don't have the law of cosines. If I knew the law of cosines, I could get that really quickly. But I don't need the law of cosines because I've got right triangle trig. And what I can do several things. But in this case, I'm going to just drop a perpendicular here. I'm going to cut this angle in half. Because this side and that side are the same, I know that if I bisect this angle, then that'll be a right angle right there. So this 55-degree angle over there, half of 110, is really nice because I can just solve for that x, and then 2x would be the distance that I'm looking for. But the sine of 55 degrees, take a look at that triangle, 55 degrees is x over 86.8, opposite over hypotenuse, solve for x. 86.8 times the sine of 55 degrees. I type that into my calculator. 86.8 times the sine of 55, and I get 71.1 and some change. So 2x, which is really what I want for the whole length, is going to be 142.2 miles. Right? Draw the right auxiliary line in there, and all of a sudden it becomes a pretty simple right triangle problem. Now, I'm guessing that for some people, their randomly generated question did not end up with two sides the same length. So I'm going to do this again with different lengths. Let's say this is 80 and this one's 90. Still keep a 110-degree angle in here. Okay. Now, how do you find that distance? Well, in this case, what I think I would do is I'd extend this side out until I can drop a perpendicular right here. I'm going to call this length A and this length B. I can find A and B, which will then help me win this right triangle. Actually, I can use Pythagoras. If I could find A and B, then I can use Pythagoras on this big right triangle, because this side squared plus the whole side on the bottom squared should be the hypotenuse squared. So here we go. How do I find angle A? Well, I've got this right triangle right here now, and I know this angle because it's the supplement to 110 degrees. So 180 minus 110 is 70. So that's 70 degrees. And I can say things like the sine of 70 degrees is A over 80. So A is equal to 80 times the sine of 70. Which turns out to be 75.1754-ish. And then I can get angle B using the cosine, because the cosine of 70 degrees in this triangle right here is B over 80. So solve for B. B is 80 times the cosine of 70 degrees, which, here we go, 80 cosine 70 in my calculator says 27.3616. And now I can get the desired distance by using Pythagoras, because I'm going to say that this is the square root of A squared plus B plus 90 squared. So I'm going to take this result, add 90 to it, square it, and then add this number squared in my calculator, and I'll be right back. It calculates to 139.3739. So either in the simpler situation where those two sides are the same, or in the more complicated situation, we can still just use regular old right triangle trig and figure out how long that hypotenuse is. It does not take the law of cosines. You have other ways that you can apply basic knowledge.